Hello everybody, I thought I would do a little short video, and you know how my short videos go, on some components. We'll go over these resistor. If you'll notice, some of the newer metal film ones now have 5 bands, and this confuses folks, and we'll go over those and maybe a little history about that. And also capacitors. I know you've seen several videos that shows an oscilloscope to determine the foil side, also some audio signal tracers and some devices built to determine which is the foil side, or the one that's either go to ground for bypass or to the lowest impedance side when you're coupling. But I have a theory, and we're gonna see. I struggled with this one for 15 minutes on an oscilloscope trying to determine the foil. This one I was able to determine right off the bat. These are, as you can very well tell, these are manufactured by different folks. So I'm thinking the construction of some of these are different and some don't have a foil. So I'm going to cut these two open. I'm going to sacrifice brand new capacitors to see. And you know, what will it prove? I don't know. It's just that sometimes you can't determine the difference. And so I think it's the way they're constructed. So I'm going to cut them open. Let's cut this one open that I know that I can find the foil side. Instead of cutting it open, as you can see on both of them, they have a little beginning end like the end of a tape. And if you'll notice, as I unroll this, it's printed several times on it. So this is just a sheet of tape that has been wrapped around this and during the manufacturing process. And look what I found here. So I think we could probably use a meter to determine which end is this. You just have to okay, that is not it. Whoops, sorry. That doesn't seem to be it either. Neither one of that. Neither one of that is to either one of those. This foil or shield is not connected to anything. And I'm trying to see if there's a, let me see it, if I can. But I've tried continuity between each lead and that, and there's no connection between the leads and that foil. As you can see, I scraped off. Thought it might have some sort of little cellophane, or, and you can see. But it's a film. It's a film there. But I can't get continuity with that. So if either way, I thought it might have been insulated. I'm sorry if I'm off camera. You get occupied what you're doing. as you can see, I got down to a real shiny aluminum, and I'm getting approximately 9 ohms there. So, and the other side I am getting nothing. So as you can see, we do have foil on this side, but it was just under several layers of cellophane material, and that's to insulate it properly. All right, so we see this has a foil in it. Let's go to the other one and see what it looks like. Okay, so that proves that I was wrong. They are built very similar. The only difference that I really see is the actual area of it. But as you can see, once you get past this protective coating, you do have a foil underneath there. So, and it does, but the only, like I say, I was able to determine it on this one with an oscilloscope, but could not with this one. I don't have any other testing equipment for the foil side, but I could detect it with this, but not this. And the only thing I could think of is the extra size of the foil gave me more inductance into that capacitor or that foil to differentiate between the two. But they're basically built about the same. So what's the conclusion? Some of them you're able to determine the foil side. Now this is my observation. And some I can't. And I've checked around with some of the other guys, and they do the best they can, and if they can't differentiate it, and I've heard that I've talked to some, and they say they've had problems doing it also, and if they can't differentiate it, then they don't worry about it, and they just put them in. And I don't know of any problems that anybody's run into because they've put them in backwards or not. If they have, they haven't identified it or reported it or anything like that. I'd like to hear y'all's take on all this and see what you all do, and see if y'all are having problems determining the foil side of your capacitors. Okay, let's go over some resistors. I think this particular one here is what most of us grew up with and identify with. But if you're working on a lot of older stuff, you'll run into these. But nowadays you're starting to see more of these 5-band resistors. So let's start with a little history to start with, and then we'll go over some of these, what some of these codes mean, what have you. But somewhere, before 1920 and real early, the radio manufacturers, they did whatever they wanted to. There was no standard, so they would either make their own color codes up or print on it or whatever. I've seen schematics on some early stuff that says this resistor has a color code of blah blah blah, and it didn't match anything that we know today. It was just what they did. So somewhere around 1924 or so in Chicago, there was 50 radio manufacturers got together, and they formed a trade group, and it was called the Association of Radio Manufacturers. And that name didn't stick. It quickly changed to the Radio Manufacturing Association, or the RMA. And I've seen this stamped on radios. I think, well, here's a picture of one right there. So somewhere in the late 20s, the RMA set up the code, and it started out with the body, end, and dot. Okay, body is brown, which is 1. The end is green, which is 5. So that's 1, 5. And then orange is the dot, and so that is the multiplier, and that's 1, 2, 3. So that's 15,000 ohm resistor. Now, if you'll see, it's got a silver band, which you don't see on many dog bones. And this is a 10%. And we'll go over the tolerances a little bit later on. But take a look at this one. This is an IRC. And let's just do the color codes, okay? 4, 5, that's 45 with 2 zeros, 4,500 ohms. Everybody agrees with that? Right? What does that say? 450 ohms. And I checked it on the meter, and it's 400 and something ohms. So you're saying, okay, maybe that's a tolerance band. It says 20%. If there's no band on it, the tolerance will be 20%. But this is marked what the resistance is, but it has a different color code. So this was something that they made totally independent there. So, of course, the colors that they used was supposedly to follow the visual spectrum of light. Okay, black, brown, red, orange, yellow, green, blue, violet, gray, and white. Now, they wanted to use indigo, but a lot of people doesn't or can't distinguish the difference in blue, indigo, and violet. They think it's all the same, so they just used violet. Okay. Then I touched on this tolerance thing a little bit in part 3 of the RCA 87T. But in 1952, the International Electronics Commission, they came up with what was called the E series, and this is like the E12 series is what we normally see, and the numbers and multiples thereof is 1, 1.2, 1.5, 1.8, 2.2, 2.7, 3.3, 3.9, 4.7, 5.6, 6.8, and 8.2. And that's all based upon a 10% tolerance. And so what that means, that if you've got one of those resistors, and a good common one in the older radios is 490K. All right. You can buy 490K, but most standard stuff is 470K. All right. So if you've got a 470K resistor and it's within 10%, that's 47,000 ohms. And you add that to your 470K ohms, and that goes up to 517. So 490, if you go 20%, either side of 490, it falls within that 470 ohm. So most people would just use a 470,000 ohm resistor. Remember, the older radios use 20%. Okay? A lot of people may remember these. I picked this up at Radio Shack, about 1 million years. It was last century, last millennium. I've had this thing for 40 years, I know, at least. And sometimes I still use it to double check. It's just like a while ago with this resistor. I double checked because I just knew it was 4,500 ohms. But I think you can still buy these, not necessarily from Radio Shack, but you can still buy these. But the tolerances, it tells them right here. That's the capacitor tolerance, but the resistor tolerances, and this is on the 4-band. Now, most resistors are 4-band. Let me get another example. We'll just use this one. This is a 4-band resistor. Okay, we've already gone the first digit, second digit, and then the multiplier, and then the 4th band is the tolerance. Okay, if there is no band, that's still considered a band if there's not one there. That's still the 4th band. And if there's none, it's 20%. And in the older radios, most of them were 20% within there. This one is silver, so the silver is 10%. And like I say, this is the one that we grew up with, most of us did. And the silver was 10%. The gold was 5%, and then you get into the red ones, which is 2%. When I was growing up, if I had a 10%, was great, and the 5%, I mean, I just didn't see them, you know. And red, no, forget it. All right, so now we're doing these. Okay, and everybody getting confused by these yet? The end band is the tolerance. That's the farthest away, and this one is brown, and it falls into the 5-band. Brown is only used in the 5-band that I'm aware of. Anyway, it is a 1% tolerance. Okay, and with the 5-band, you've got brown, which is 1%, red, which is 2%, green, which is 0.5%, blue, which is 0.25%. And then violet is 0.1%. You get into the precision resistors. So let's look and see how we do it. And this gets confusing. Most people put them on an ohm meter and they determine what the value is. You still have your first digit, which is red, which is 2. The next one is violet, which is 7. So now we have 2 and 7. Now here's where everybody gets confused. The 3rd band in most, what we learned, was the multiplier. In this case, it's not anymore. It's the 3rd digit. So what is black? Black is 0. Okay, so now we have 2, 7, 0. Okay? 270, and then the multiplier is red, which is times 100. So that's 2 more zeros. Okay, so that's 27,000 ohms at 1% tolerance. Let's talk about some more multipliers and then we'll wrap this up. If you'll look, here's your tolerance band, which is 5%. The first digit is 2, the second digit is 2, so that's 22, and then the multiplier is gold, which is a division. You divide this by 10, which is, you divide 22 by 10, and that's 2.2 ohms at 5% tolerance. Now, if that were to be silver, that multiplier or divisor was divided by 100, or this would have been a 0.22 resistor. Most resistors come in when you order them already pre-packaged, and but I always check mine. I got an order yesterday, and one of the values were off by a factor of 10, and it was one of the newer ones like this, and it's a very common mistake. It's real easy to do. Your ohm meter, always check it before you put it in. Even though you may be reading that, or the package may say that, always check it with your ohm meter before you stick it in. It could save you some heartache down the line. So I hope this was informative, and I thought I would just put in a little video trying to clear some of this stuff up, and maybe brought up more questions than answers. But anyway, if you've got anything to add, we'll pin it in the comments. And I've always told people to read the comments on all the videos you watch, because there's a lot of information that's shared in those comments that you would miss otherwise. The videos are supposed to give you a lot of information, but the comments can give you as much or more, and even correct some things that's in the video. So read your comments, read the comments. That's what they're there for. So we'll close this little video out for now. So hope everybody stays safe out there and stays well. So from Larry from the hills of Tennessee, thanks for watching.